So given that ax equals b is a linear system of m equations and n unknowns, where a is said to be the coefficient matrix, x is said to be the column matrix that contains the unknown variables, and then b is the constants that are seen on the right hand side of the equal to sign. So given that ax equals b is a linear system of m equations and n unknowns, the system is said to be consistent if the rank of a, which is the rank of the coefficient matrix, is equal to the rank of the augmented matrix AB. Now, what do we mean by the rank of a matrix? Now, the rank of a matrix is said to be the number of non-zero rows if the matrix is expressed in the row echelon form. Now, in a consistent system, if the rank is equal to the unknowns, then the system is said to have a unique solution. If the rank is less than the unknowns, there are infinite number of solutions in the system. On the other hand, the system is said to be inconsistent if the rank of A is not equal to the rank of AB. That is, if the rank of the coefficient matrix is not equal to the rank of the augmented matrix. Now, in such a system, the system is said to have no solution at all. So in summary, given that ax equals b is a linear system of m equations and n unknowns, the system can either be consistent or inconsistent. The system is said to be consistent if the rank of a is equal to the rank of ab. Now, also in a consistent system, the system is said to have a unique solution if the rank is equal to the unknowns, and infinite number of solutions if the rank is less than the unknowns. On the other hand, the system is said to be inconsistent if the rank of A is not equal to the rank of AB, and in such a system, we say that the system has no solution. Now let's try some examples on this. Example 1. Find the value of k such that the following system is consistent. Now, in the previous section, we said that for a system to be consistent, the rank of the coefficient matrix should be equal to the rank of the augmented matrix. That is, the rank of A should be equal to the rank of AB. Now, to find the value of k such that the following system is consistent, first of all, we are going to rewrite this system of linear equations in a form of augmented matrix, and then we transform that to the row echelon form, and then we proceed with the rest of the solution. So first of all, let's write this system of linear equations in a form of augmented matrix. Now let's write down the coefficients of x, y, z, as well as the constants on the right hand side of the equal to sign. So we have 1, 2, 1, 1, 2, 3, 1, 3, 3, 4, 1, k. Now, to transform this matrix to the row echelon form, we are going to perform elementary row operations on this matrix, such that we have the elements in the leading diagonal to be 1 and the elements below the leading diagonal to be 0. So that's exactly what we are going to do. Now, focusing on this value, how do we make this value go to 0? So to do so, we are going to perform the operation on row 2, and the operation is we are going to multiply row 1 by 2 and then subtract that from row 2. So the operation is row 2 minus 2 times of row 1. Simultaneously, if we want to make this value also go to 0, then we perform the operation on row 3, and the operation is we multiply row 1 by 3 and subtract that from row 3. So that is row 3 minus 3 times of row 1. So elements in row 1 remains unchanged or remains the same, and then we make changes to row 2 and row 3. So for row 2, we have 2 minus 2 times 1, and then 2 minus 2 times 1 is equal to 0. We have 3 minus 2 times 2. 2 times 2 is 4. So 3 minus 4 is negative 1. And then 1 minus 2 times 1. 2 times 1 is 2. So 1 minus 2 is negative 1. And then 3 minus 2 times 1. 2 times 1 is 2. So 3 minus 2 is 1. Now to row 3. So for row 3, we have 3 minus 3 times 1. 3 times 1 is 3. 3 minus 3 is 0. We have 4 minus 3 times 2. 3 times 2 is 6. So 4 minus 6 is negative 2. And then 1 minus 3 times 1. 3 times 1 is 3. 1 minus 3 is negative 2. And then lastly, we have k minus 3 times 1. And that is k minus 3. Now at this point, let's focus on making this value go to 0. So we perform the operation on row 3. And the operation is, we are going to multiply row 2 by negative 2 and then add that to row 3. So we have negative 2 row 2 plus row 3. Now negative 2 times 0 plus 0 is still 0. Negative 2 times negative 1 is plus 2. And then plus 2 minus 2 is still 0. Negative 2 times negative 1 is 2. 2 plus negative 2 is still 0. Negative 2 times 1 is negative 2. And then negative 2 plus k minus 3. This becomes k minus 5. So we have this to be k minus 5. Let's make this value 1. So we perform the operation on row 2, and then we multiply negative 1 by row 2. So we have 1, 2, 1, 1. Negative 1 times 0 is 0. Negative 1 times negative 1 is 1. Negative 1 times 1 is negative 1. And then we have 0, 0, 0, k minus 5. So this matrix is said to be in the row echelon form. Now in the previous section, you recall that the rank of the coefficient matrix should be equal to the rank of the augmented matrix for the system to be consistent. Now let's try to find the rank of the coefficient matrix. So this is the coefficient matrix, that is the 3 by 3 matrix, and then the whole of this is the augmented matrix AB. So to find the rank of the coefficient matrix, then basically we are going to focus on the coefficient matrix and then count the number of non-zero rows. So we have this to be the first non-zero row, and then this to be the second non-zero row, which means that the rank of the coefficient matrix A is equal to 2. Now what do you think will be the rank of the augmented matrix AB? So we are going to focus on the whole matrix. We have this to be the first non-zero row, the second non-zero row, and then we have the third non-zero row. So the rank of the augmented matrix is 3. Notice that for the system to be consistent, the rank of A should be equal to the rank of AB. However, we have the rank of A to be 2 and then the rank of AB to be 3, which means that the system is inconsistent. Now, for the system to be consistent, we need to find the value of K such that this value becomes 0. Now, if you are able to get the value of K which makes this value go to 0, then the number of non-zero rows for the augmented matrix AB becomes 2, and then we say that the system is consistent. So what do you think will be the value of K that will make the system consistent? So to find the value of K, we basically equate this to 0. So we have K minus 5 equals 0, and then K is equal to 5. So we say that the value of K that will make the system consistent is equal to 5. So 5 minus 5 is 0. And then if you want to count the number of non-zero rows for the augmented matrix AB, then that's going to be 1, 2. And then we have the last row to be a 0 row. So in conclusion, we say that the value of K that will make the system consistent is 5. Now let's move on to the next example. Example 2. Show that this system is not consistent. So first of all, let's write this system of equation in the form of augmented matrix. So writing the coefficients and the constant on the right hand side of the equal to sign, we have 1, negative 2, negative 3, 1, negative 4, negative 3, 7, negative 1, 1, negative 3, 2, negative 5, 4, negative 3, 7, negative 3, 6, 9, negative 6, negative 1. At this point, we are going to convert this augmented matrix to the row echelon form by performing elementary operations on this augmented matrix. So we want to make the element in the leading diagonal go to 1 and the elements below the leading diagonal go to 0. Let's do that together. So focusing on this value, to make this value go to 0, we perform the operation on row 2 and then we multiply row 1 by 3 and then add that to row 2. So we have 3 row 1 plus row 2. So how do we make this value also go to 0? We perform the operation on row 3 and the operation is we multiply row 1 by 2 and subtract that from row 3. So that is row 3 minus 2 times of row 1. And also for this value, we are going to multiply row 1 by 3 and then add that to row 4. So we perform the operation on row 4 and the operation is 3 times row 1 plus row 4. So row 1 remains the same and then we apply changes to row 2 through to row 4. Now we have 3 times 1, which is 3, plus negative 3 is 0. 3 times negative 2 is negative 6, plus 7 is 1. 3 times negative 3 is negative 9, plus negative 1, that becomes negative 9 minus 1, and that is negative 10. 3 times 1 is 3, plus 1 is 4. 3 times negative 4 is negative 12, plus negative 3 becomes negative 15. Now to row 3. 2 minus 2 times 1, that is 2 minus 2 is 0. Negative 5 minus 2 times negative 2. Now negative 2 times negative 2 is plus 4. So negative 5 plus 4 is negative 1. 4 minus 2 times negative 3. Negative 2 times negative 3 is plus 6. So 4 plus 6 is 10. And then we have negative 3 minus 2 times 1. That becomes negative 3 minus 2. And that is negative 5. And then lastly, we have 7 minus 2 times negative 4. Negative 2 times negative 4 is plus 8. So 7 plus 8 is 15. Now to row 4. 3 times 1 is 3, plus negative 3 is 0. 3 times negative 2 is negative 6, plus 6 is 0. 3 times negative 3 is negative 9, plus 9 is 0. 3 times 1 is 3, plus negative 6 becomes 3 minus 6, and that is negative 3. 3 times negative 4 is negative 12, minus 1, negative 13. So at this point, we have these values to be 0, these values also to be 0. We are left with this value. Let's try to make this value go to 0. So to do so, we are basically going to add row 2 and row 3. So we perform the operation on row 3, and then we basically add row 2 and row 3. So we have 1, negative 2, negative 3, 1, negative 4. For row 2 we have 0, 1, negative 10, 4, negative 15. Now to row 3, let's perform the operation. So 0 plus 0 is 0. 1 plus negative 1 is 0. Negative 10 plus 10 is also 0. 4 plus negative 5 is 4 minus 5, that is negative 1. Negative 15 plus 15 is 0. And then we have 0, 0, 0, negative 3, negative 13. Now at this point, it is more appropriate to convert this value to 0. So what we are going to do is we are going to perform the operation on row 4. And the operation is we are going to multiply row 3 by negative 3, and then we add that to row 4. Now if you multiply row 3 by negative 3, then negative 1 times negative 3 becomes 3, and then 3 plus negative 3 is 0. So let's multiply row 3 by negative 3, and then we add that to row 4. So we still have 1, negative 2, negative 3, 1, negative 4, 0, 1, negative 10, 4, negative 15, 0, 0, 0, negative 1, 0. And then for row 4, negative 3 times 0 is 0, plus 0 is 0. So we have 0, 0, 0. Negative 3 times negative 1 is 3, plus negative 3 is 0. Negative 3 times 0 is 0. 0 plus negative 13 is still negative 13. So this augmented matrix is said to be in the row echelon form. Now we are to show that this system is not consistent. Now for the system to be inconsistent, the rank of the coefficient matrix is not equal to the rank of the augmented matrix. So let's try to find the rank of the coefficient matrix as well as the rank of the augmented matrix. So this is the coefficient matrix, that is from this point through to this point, and then the augmented matrix is everything that we have here. Now to find the rank of the coefficient matrix, let's count the number of non-zero rows of the coefficient matrix. So we have 1, 2, 3. So the rank of the coefficient matrix is equal to 3. Now let's find the rank of the augmented matrix. So we have this to be the first non-zero row, second non-zero row, third non-zero row, and then fourth non-zero row, which means that the rank of the augmented matrix is equal to 4. Therefore, since the rank of A is not equal to the rank of AB, we say that the system is not consistent, or better still, the system is inconsistent. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.